On this second video on Thursday, April the 8th, 2021, we've gone through the setup of our current voltage regulated full-wave rectifier, and now we're going to turn it on. We're going to first apply control input power, 120 volts, and by applying 120 we power the 6100 board, which in turn controls and fires the regulator board. We still have our phase loss. So we got to bring in this particular case, for illustration purposes, 480 volts, three-phase, and that has cleared the phase loss. Now we can enable the unit, basically turn it on, and we have the way that we're going to control this to illustrate how it gets controlled is we have the current command at maximum, and we have the voltage command at minimum. So we have a delay angle of 110 degrees, and we have an output voltage of about 10 volts. If we wanted to get rid of that, we can always increase our delay angle range to eliminate that and to make it a 2-0. So I'm going to ask Tony to start increasing the 420 milliamps. 6, 7, you want to stop at 12, Tony? Or 11, that's fine. 12 milliamps, that current command didn't change. Now our DC output is 262 volts, our AC input is 477 volts AC. At this point we have 24 millivolts of current feedback out of a 50 millivolt shunt. It's a 30 millivolt shunt, so 24 millivolts, it's approximately half of 30, which current wise we can check on the DC output that we have 13.8 according to our probe, and the 4 volts maximum voltage feedback, it's only 2.6, because this will give us 4 volts when we get 400. So go ahead, Tony, and increase the current command until we have 400 volts DC. The voltage command has gone to 17.35 milliamps at this point because of our load, because we're only drawing 20.9 amps, or 30 amp 50 millivolt shunt, it's 36 millivolts, and because we've sized our resistors correct, we have 4 volts DC of feedback. Again, here we have 51 degrees of delay angle. Our output is 400, and again, something to consider is this big peak to peak voltage that we have. Tony, can you go to 20 milliamps? Can you make the delay angle minimum? Oh, yeah. Now you're not able to go, because we've limited to the 400, as opposed to getting up to 600 volts.
Yes.
All right. So go ahead and bring it back to 20. So basically, I'm asking Tony to go past the limit, and the voltage limit is at 4, so we can't go higher. If we wanted to go to 600, we will have to adjust our resistor so that we get 4 volts at 624. So now let's go ahead and do that. The same thing, Tony, with the current command. So we're coming back, and again, we can keep that 20, and we're coming in low, and now we've reduced our DC output voltage. Again, we have the same conditions, about 11 volts, 108 degrees, and we have and then Tony, can you just randomly take them to 10 and 10 milliamps and 10 milliamps? Okay. Because again, you can control this independently to whatever limit in command. So we have 10 and 10. In this particular scenario, we have 140 volts DC, 12 millivolts, about a quarter of the 50 millivolt feedback, or 7.3 amps. Our voltage feedback is 1.3, and again, here we have a rectifier output. The advantage of using this is that we can set independently the current command, the voltage command, and we can set our limits where we don't go past that maximum limit. So this unit will give you the firing angle that it's indirect as a function of voltage and current command. And this is pretty much the end of this second video.